All right, this is the last section for transformations, and this one's going to focus on composite transformations. So what are composite transformations? So these are when one transformation is applied to a figure and another transformation is applied to its image. So it's basically one or two transformations, or three, can be as many when they're applied. So when you think of multiple translations, they can be written as one single translation. So here's a quick example. So here's translation number 1. Here's translation number 2. And so instead of writing them separately, you can just write it as that single transformation. So it went to the right 3 and then down 5. And then we took that image and went to the right 4 and down another 2. And so we can just write it as that. Now, it's not always just two different translations. It can be different types of transformation. So we're going to write a rule for this one here. So on this one here, we have triangle ABC down here. This is the pre-image. Okay, here's image number 1, and then here's image number 2. So you have to kind of call it out. What is each one? This one is a reflection over the x-axis, and then it looks as though as we slide it to the right and up. So let's write that down. So we have our first one being a reflection Okay, so that was the first one, and then the second one is translation. We move to the right, and let's be specific here. So we're going to the right. I'm going to just focus on a 1, 2, 3, 4, 5, 6 to the right, and then up 2. So to the right 6, and then up 2. Okay, so just kind of write it down in words. Explain what the composite transformation is. And so when we write our rule, we want to write the final outcome. So another good strategy to use is write down the point A and focus on A, or B or C. So I'm going to use A. A is at -5, comma, -2. Okay. And then A prime is at -5, comma, +2. Okay, just like we learned on our rules that you just change the sign on the y. Okay, and then you want to look at your final outcome, which a double prime is at 1, comma, 4. Okay, so we want to write a rule on how we get from this number to that one there. So your rule always starts off with x comma y maps onto, and then we want to write our final rule. Well, let's see, how do we write a rule for the first one? Well, we just change the sign on the y, okay? So I'm going to put x, comma, change the sign on the y. And then how do we write it to represent the translation? Well, when we go to the right 6, we want to add 6 to the x variable. And when we go up 2, we want to add 2 to the y variable. Okay. Now, the last thing you need to do is you need to check and you need to substitute A into this rule and see if it comes out with a double prime. So I'm going to get a different color here. So A is at -5. So if I plug in a -5 here, add 6, and then y, xy is -2. So I have a negative, and then I'm going to plug in a -2 plus 2. So -5 plus 6 equals 1. And then negative means that this is a positive. So 2 plus 2 equals 4. Is that the one that we wanted for a double prime? Yes, a double prime was 1, comma 4. So this is our composite rule. Okay. So you'll be able to do, you'll be asked to do that on your homework. Come up with some rules for the composite transformation. All right, let's do a couple of investigations of two special types of composite transformations. So here we have composite transformations of reflections. So here we have this one being reflected over here. So it says investigate the reflection. So this one's being reflected over this line. And then this one's being reflected again another time. So there's another reflection. So reflection and then another reflection. And then these two lines are parallel. So let's make note of that. So it says, how does the second image compare to the original? So how does this one, this is our second image, compare to this one? Well, look, they're facing the same way again. Okay, and then it says name a single transformation that transforms the original to the second one. Well, if you think about it, it's just like a translation. Okay, so that's actually the first part of the conjecture. So this is a translation. Okay, so the composite, the composition of the two reflections that go across two parallel lines is equivalent to a single translation. So that's all it is. So whenever you reflect over parallel lines, it's just a translation. That's it. Okay. Second thing, step 3, it says use a ruler to measure the distance between a point in the original and its second. So we have A marked, and so let's measure from A to A prime. So I'm going to get my ruler. Let's use red. So from A to A prime, it looks as though it is about 5.8. So from A to A double prime, sorry, I said A prime. That is about 5.8 centimeters, okay? And then it says compare the distance between the parallel lines. So now let's measure this one here. From here to here. This one looks like it is, I can hold this still. That looks right on the 2.9 mark, 2.9 centimeters. All right, so how do they compare? So how does 2.9 compare to 5.8? 2.9 looks as if it's exactly half of 5.8. And that is the situation that takes place whenever you reflect over parallel lines. What the distance from the pre-image to the second image is always going to be double the distance between the parallel lines, okay? So let's write that down. In addition, the distance from any point to its second image under two reflections is double the distance, or twice, whichever one you want to write, okay? Twice the distance between the two parallel lines. Okay, so that's a unique little double reflection. Okay, let's go look at one more. This one is another composite transformation, and this is going to be two reflections again, but the lines are slightly different. So it says investigate the reflections. So we have two lines here. Let me get my highlighter. We have this line here, which is where the first reflection takes place. So this figure right here looks like it's a quadrilateral. This quadrilateral is being reflected over here. Okay, so let me get my pen real quick. So this one is being reflected there. Okay, and then this image looks like it's being reflected over the other line. So let me get my another highlighter color. So from here to there, this one is now being reflected over that pink line. Okay, so another reflection takes place. So let's make note of that. So we have two reflections. So reflect and then reflect again. Only this time we don't have parallel lines. We have intersecting lines. So the pink line is intersecting the blue line. And so it says, how does the second image, so this one over here with A double prime, compare to the original? So how does this one compare here? From here all the way to there. From there to there. Okay, what single transformation does it look like? Well, it looks like as though it is rotating about this point right here. Okay, because it kind of stays in the same direction and rotating around that point. And so that's what it is. So this one is going to be a composition of two reflections across a pair of intersecting lines is equivalent to a single rotation. That's what goes in the first blank. So that's what it really ends up being. Okay, so the next thing it says, with the protractor measure angle X, which is the angle formed by the intersecting line. So that's the one between the pink and the blue. And then it says measure angle Y, which is the angle formed from A to A prime. So the one from the pre-image to the second image. How do those angles compare? So let's look at that. Here's the protractor. And if you have a protractor, let me move this stuff out of the way so I can be a little bit more accurate. So I guess I'll measure angle X first. So it looks as though, this is going to be high. It looks as though as angle X could be about 57 or 58, so around there. And then now let's measure from A to A double prime. And that looks like it is 114. Okay, so let's write that down. So we said the measure of angle X was about 57 or 58, okay, around there. And then the measure of angle Y, which was from A to A prime, that one is about 114. So what do you notice between those two angles? This is exactly double, or it doubles. Okay, so kind of the same situation over there. So it says the angle of blank is the blank, I'm sorry, is blank the acute angle between the pair of intersecting lines. So the angle of rotation, because remember this was, so this is like our angle Y. So I'll just put that in parentheses. So that angle of rotation is blank the acute angle between the pair of intersecting lines. So the acute angle, which is between the intersecting lines, is the angle X in our picture. So how do you compare the angle of rotation, which was angle Y, compared to that one? It is double or twice, just like we wrote on the other one. It is double the acute angle or twice the acute angle between the pair of intersecting lines. Okay, so remember these in case I ask you questions on this on an upcoming quiz. And that is it.